Alright, first let's answer this question. So we should work out the nth term of the quadratic sequence. Okay, for us to know whether a sequence is quadratic, if the second difference is 2 or a multiple of 2, that is, if it is 2, second difference, or 4, 4 which is 2 times 2, 6 which is 3 times 2, okay? Of course, quadratic sequence is a sequence of the form, maybe un, the simplest form is un because n squared. That is 1, 4, 9, 16, and on and on. Now, what do I mean by second difference? See, we have 5, 0, 5, 12, 21. Now, if I am to move to 5 from 0, the difference is 5. I will add 5. I will add 7. I will add 9. See that? Now, this is the first difference. First difference. First difference. That is 0 minus 5, 5 minus 0 is 5. 12 minus 5 is 7. 2 minus 12 is this. Now, second difference is 7 minus 5, which is 2. If I add 2 here, I will get to 7. So you see, this is second difference. Because the second difference is 2, is a quadratic sequence. So what we now do is, now let's call this, this is our sequence. Let it be u subscript n. Okay? Now, we know quadratic sequence is n squared. Quadratic sequence is n squared. Now, n squared is, if n is 1, this is 1. If n is 2, here is 4. If n is 3, 9. If n is 4, this is 16. And on and on. Now, how do I move from quadratic sequence to the main sequence, whose n term we're to determine? Watch this. If I'm to get to 0, I will have to add -1. So -1 plus 1 will give me 0. If I'm to get to 5, I will have to add 1 to so that you have 1 plus 4, 5. If I'm to get to 12, I will have to add 3. That 3 plus 9 is 12. If I'm to get to 21, I will have to add 5. So our un will be whatever this is plus whatever this is. In other words, this term plus this term gives us 0. Now, look at this. This is a sequence. So it looks like, to me, an AP. Watch that. The difference between 1 and -1 is 2. That is 1 minus 1. 3 minus 1 is 2. 5 minus 3 is 2. So it has to be consistent with the n term of an AP, a plus n minus 1, or where a is the first term, which is -1, and is the term we are looking for, and the n term. This is a common difference, which is the difference between successive terms, which is 2. So un here is -1 plus m minus 1, 2. So if you open the bracket, you have -1 plus 2n minus 3, which is 2n minus 3. So what defines what we have here is 2n minus 3. So if this number is this plus this, and this is this plus this, so this will be this plus this. See that? This is this plus this, this is this plus this must be this plus this. So un, which is the n term of the quadratic sequence, equals n squared plus 2n minus 3. Let's check for the veracity of the equation we've produced. So if you take n1, n1 is 1 squared plus 2 times 1 minus 3. This is 1 plus 2 minus 3, which is 0. So this is correct. Luckily, we are correct. Let's check whether we are correct. Second one, 2 squared plus 2 times 2 minus 3. 4 plus 4 is 8, minus 3 is 5. It's correct. Let's check the third one, 2 squared plus 2 times 3 minus 3. This is 9 plus 6 minus 3. 15 minus 3, 12. It's correct. And the first term is 4 squared 2 times 4 minus 3. 16 plus 8 minus 3. 16 plus 8 is 24 minus 3 is 21. So that's correct. So this is the nth term of the quadratic sequence. Thank you very much.